Welcome to our celebrating, I'll have to get the title right, Interdisciplinary Sustainability Research Conference. So this is the first of a kind, bringing together lots of different Embury projects and showcasing the fantastic work that they've been doing. I'll say a little bit more about Embury in a minute. So first thing, housekeeping. We're not expecting any fire alarms. If the fire alarm does go off, you need to get out via the nearest exit, which for most will probably be down the stairs and out to the front. The assembly point is at the front of the building near the Hyatt Hotel, but hopefully that won't happen. We are recording today and there will be photographs taken. If you don't want to be included in any of those, then let one of the team know. We've all got our Sustainable Futures branded t-shirts on, so you can't miss us. Doors, that was the other thing, wasn't it? So the doors in here are a bit of a pain because they're at the front and they make quite a lot of noise as you're coming and going. So all we ask is if you do need to get up during one of the talks, if you just be careful and just make sure the door closes as quietly as possible because it can be really disruptive to the speakers otherwise. I think that's all of it. Yep, don't block the walkways. And any first aid issues, again, let anyone in one of these fabulous green t-shirts know. So Alex, who's organised most of today, has helpfully put together a map. I'm hoping you've probably all found where everything is. That everything's not that far away, but do shout if you get stuck at all. Really grateful. We are actually missing one of our partners at the minute. I'm hoping he'll be here in a minute. That we've been able to put this on today in conjunction with the Manchester Environmental Research Institute, which Tim represents, the Royce Institute, which Michaela is here represented, and the Sustainable Consumption Institute, which Matt Patterson should be here representing, but isn't. So I might have to stand in for that one because I'm also part of the SCI. So we're really grateful for having these collaborations in place to enable today to take place. So here's the agenda for today. There are a couple of alterations because unfortunately we've got a couple of speakers off sick. So Ben Parks won't be in the first session and then Sophie Nixon won't be in the last session. So that's probably going to mean we've got slightly extended breaks, but it also means that we won't be being really strict with the speakers as well, and they can have a little bit of extra time, not too much, because if we say that, they could be going on for an hour or so. So download the QR code, the agenda's on there, and then you can keep that handy for the day, and then you know what's coming up and when, and importantly, when lunch is as well. So I want to say a little bit about Sustainable Futures. And we've been around for a while now, so I'm hoping that most people will know what I mean by Sustainable Futures, but I expect we've got a few external people to the university here as well today. So Sustainable Futures is one of 4 research platforms across the university. And they were established because the university is so humongous, it can be quite difficult to get people to work together. Each of our faculties is the size of a normal university. So the platforms were established as a means of trying to encourage and support interdisciplinary research, which is across disciplines and across faculties. Here he is. I thought I was going to have to step in then. Sorry, I'll just have a little laugh. So the platforms were established to enable interdisciplinary research, and what we're trying to do is bring people together to provide the spaces and the opportunities for people to collaborate together. So we do lots of different events, lots of activities. So networking events, some aimed at ECRs, some aimed at generally at academics across the university. We have a seminar series, lots of workshops and sandpits. Some of those are around different funding applications. Some might be more generally about creating communities and networks across the university. And we've had some interesting networks come out from the platform and the platform's activities as well, which are proving really fruitful. So lots of opportunities to engage, and we hope that you will. So the way that we're organised is myself as a deputy director, Mike Shaver, who's hiding at the front here, who is the director. And then we've got a great core team who are not mentioned on there. And then 6 fantastic challenge leads as well, which cover for us the breadth of sustainability as best that we can. And you can see each of the names below if you want to contact any of them in the areas that they work in. So today's event was put together because we have at Manchester a small grant, it's not that small, but not to a social scientist anyway, small grant scheme called Embury, which is about basically enabling interdisciplinary research to take place within the university. And again, it's aimed at early career academics too. So we wanted to have an opportunity to bring those different projects together and to demonstrate the impact that they're having, because they sort of they happen and they go away again, and we don't really hear that much about them. And actually, a lot of them have been incredibly successful and had a great deal of impact and activities associated with them. So we're really pleased today to not just be bringing past Embury projects together and the present ones to talk about the exciting things that they're doing, but also to be able to launch the next Embury call, which will be coming out in, is it January that we're going to launch it? Yeah, 14th of Jan it will launch with the deadline of 28th of February. So if anybody is thinking about applying, please keep your eye on the internet, because that will be, and also on our newsletter, which you can sign up for if you've not already in a moment, for that coming out. So the Embury call is organised basically around the platforms. So there's the 4 key platforms mentioned up there and what their priority areas are that they're looking for. So when you fill out your Embury application, you need to assign to at least one of them. You can assign to 2 and show how you meet those priority areas, one or more of that particular platform. So have a look. When it comes out, there'll be more information after Christmas. But all I can say is you will obviously see some of the great things that Embury projects can do and the different things that they've gone on to do since having that initial seed corn funding. I'm just going to press all the buttons for this one. Oh, wrong one. So if you do want to hear more about the events we've got going on, please do sign up. We've got a newsletter, a X Twitter page. I think we're on Blue Sky now as well. Not entirely sure if that's happened. One big thing we've got coming up that I wanted to mention today, we've also got our annual conference today, but on the 23rd of January, we've got our annual public lecture as well, the Albatross Lecture. And that's going to be given by Jared Mcgrath, who is an academic at Alabama University, whose work is on the illegal trade in exotic plants, particularly cacti. And he has written a book called The Cactus Hunters, which is a Sunday Times bestseller. So it promises to be a really great event. As along with the conference, we've got a museum tour of the Wild exhibition, a guided tour that the museum at Manchester are going to put on as well. So have a look out for that, and please do sign up to the newsletter. So I'm going to hand over now to the first of our collaborators, and that's Michaela Kiernan from the Royce Institute.
Hi, good morning, everybody. I'm Michaela Kiernan, and I work as a Research and Business Engagement Manager at the Henry Royce Institute, and we're delighted to be helping to sponsor today's event, and it's great to see such an interdisciplinary audience. So if you're not familiar with the Royce Institute, we were set up with funding through the UK government, through EPSRC, and we were established to bring together the UK's materials research community. And so our mission is to enhance advanced materials research to provide a positive economic and social impact for the UK. And so our main hub building is here within the University of Manchester campus, but we're also a partner of 11 universities and institutes across the UK, and we are, and together collectively are able to provide the UK's materials research community with access to state-of-the-art facilities, also funding opportunities, not forgetting expertise through the research community within in those universities together. So in particular, with our research areas at the Henry Royce Institute are here to help facilitate and support to overcome the global research challenges, to be able to support to see how our materials research support can help various challenges. So in particular, we have our electrochemistry research area, which is looking at developing new materials for the next generation of energy storage and battery optimization. And then we've got other research areas such as biomaterials, so looking at, next generation of antiviral coatings, and as well as looking at more broader challenges as, looking at how you can, optimize bio-based materials going forwards in the future. And so, just to summarise, today I think we've got a couple of people who are based in the Royce Institute that will be on one panel sessions later today. But I'll be around, so if you've got any particular questions, interested in how you can engage and how you can access Royce facilities, I'll be around to answer any questions. And next, I'll be handing over to Matt.
Thank you, and apologies for being late. I was pretty sure in my thing I'd read the programme starting at 10:15, but clearly my mistake, sorry. So yes, I'm Matt Patterson. I'm the director of the Sustainable Consumption Institute, which is the main institute in the Faculty of Humanities dealing with sustainability issues. It's run jointly between the School of Social Sciences and the Business School, but we also have people involved from the other schools in Faculty of Humanities and do quite a lot of work across faculty boundaries as well. We've just been, one of the things we've done this year is have a fairly extensive exercise amongst SCI members of thinking about what actually holds us together and what types of questions we want to use to sort of orient our work. And one of that's been, and that's produced a new research agenda and strategy. So I'll just say a couple of things about that. And that figure is essentially exemplifying how we see that sort of, so with an overall thing of understanding sustainability in a turbulent world, and then with that as a sort of orienting research question that ties a lot of the research that goes on within SCI, as well as actually out beyond and across the university. And we've then split that into three sub-themes of thinking about governing, thinking about provisioning, so systems of provision in different sectors, different aspects of sustainability, and in the organisation of daily life. Those, of course, are all interconnected with each other. But those are sort of how we sort of split things up to make things manageable. The value of the question in terms of the internal conversations is that, and I think in generally in terms of how we want to think about sustainability, is that it's quite easy to, well, easy is the wrong word. There are lots of ways that people talk about sustainability which have a sort of blueprint quality to them. That what would a sustainable world look like and how do we get there? And our starting proposition is to sort of say, well, okay, well, that's a big transformational process that we're envisaging of the materials that we use, as we just talked about in terms of the result, Royce, but also how daily life might be organised or the economic systems we live in. But those systems, the technologies, the economies and so on, are themselves always changing constantly. And they're changing in ways that we capture with the word turbulent. It's disruptive, it's unpredictable, it's complex. And so what we think of is what's valuable is thinking about how does all sorts of changes from geopolitical disruptions to political polarization to widening inequalities to new technologies, changing business practices and so on. How do those intrude on our attempts to pursue sustainability? Sometimes constraining them, sometimes enabling them. Right? And so that's the sort of overall pitch of how we see our research. In terms of what we are, we're sort of in terms of our core membership, it's a relatively small institute of about 12, 13 academics plus people on PDRA contracts and about 25, 30 PhD students at the moment. And some associates beyond that core membership that make up the numbers you see there. We've got current projects on green energy transitions, one of which I'll talk about later on, which was funded by Embury. Digital platforms and how they shape the possibilities of sustainable transport, sustainable mobilities, plastic recycling, which is a good example of a cross-faculty collaboration between Helen and Mike, basically, on recycling systems. And we've also just been able to announce a month ago that we've led the bid for a big new ESRC-funded research centre called JUST, which stands for Joined Up Sustainability Transformations, which will be led by Ciara McGregor, who's a SCI member, was also in the politics department, and will start life in the first part of next year. So you will be seeing more things about that. I will pass on next. Tim.
Thanks very much. So some of you all know me. So my name's Tim Foster. I'm based in the School of Engineering at Manchester. I'm also the director of the Manchester Environmental Research Institute. Some of you may be familiar with MERI, to use the acronym. So MERI was actually founded in 2018, initially with Embury support, and it's designed to be effectively a virtual cross-faculty research institute that brings together Manchester's expertise in different aspects of environmental research and innovation. So I took over the director role about 2 or 3 months or so ago now from Hugh Coe, who's based in Department of Earth and Environmental Sciences. So our kind of core kind of goal and mission is to develop knowledge, people, and solutions to address global environmental challenges, and particularly kind of global socio-environmental challenges. So if it really thinking about kind of tackling the impacts of human activity on different aspects of the environment. We also conduct a broader range of activity focused around supporting environmental research, but also training and innovation within the university, including work with PGRs, ECRs around doctoral training, but also around impact and outreach with external partners in government and industry and other sectors. So in terms of kind of MERI's kind of core areas of kind of thematic research focus, a bit like kind of Matt said for SCI, we're perhaps a bit earlier in this process. We're also in the process of rescoping and re-strategizing on the directions of MERI. One of the things we've done recently is start to kind of reclassify some of our kind of core thematic research areas into kind of 5 main topic areas. We've got a couple of the leads of those areas are in the room. So Marty Mentonga and Gareth Quay. Today, Gareth, I think, will be speaking later on one of the panels. So these 5 areas around conservation, land and biodiversity, around human health and the environment, particularly looking at the impacts of environmental change and climate change on human health, around water security and resilience, including both dimensions around water quality and water quantity, around environmental risks and change, particularly linked to a lot of Manchester's expertise in various aspects of natural hazards, pollution, and other aspects of environmental degradation. And finally, on kind of low carbon energy transition. So particularly thinking about how we bring environmental research expertise to the table to help with both the generation of solutions to support the transition to low carbon economies, but also thinking about what some of the environmental impacts of those transitions are. So in terms of kind of the direction of the Institute going forward, I wanted to kind of flag a few things. These are kind of, as I say, we're in the process of developing and we'll soon be launching a kind of a new research strategy for the Institute. As part of this, we're going to be launching a number of kind of what we're kind of terming research initiatives, which are going to cut across a number of our themes and really tackle bring together Manchester expertise to really try and tackle some big cross-cutting socio-environmental research challenges. We will also be having kind of an inaugural MERI annual lecture and research symposium, which we're hoping to host around about the sort of summer of 2025. And a number of upcoming events around some of the existing activity we had going on linked to doctoral training and our ECR community at Manchester. If you would like to find out a little bit more about MERI, you can drop us an email on the email address that is listed on the slide. There's also a link on the slide here of how you can sign up to our newsletter, and we'll be publicizing through that a lot of the kind of the upcoming changes to the research strategy and some of the events that are going to be going in to help shape and coordinate input into those processes and some of the events that we'll be following on. So that's what I have to say on MERI. I don't, if I'm right, Helen, I don't think we have additional slides from now. So I'm going to grab my notes. I'm not going to surprise you and say I'm not going to. Yes. Microphone seems to be working all right. No? Closer? Better? All right. So it needs to be much closer. Are you able to switch over the are you able to switch over the slides before we? Ciara, I'll do just a brief introduction. Pardon? Oh, they're all in one deck. Perfect. Okay, there we go. Sorry, my fault. Oh, okay. So I'm going to be chairing the first of the sessions that we've got today. If I move the microphone too far away from my face, please someone wave their hand at me and I will move it closer again. It's a bad habit. So the first of these sessions that we've got today is focusing on technology for sustainability. So we're going to have, we were due to have 3 talks. Unfortunately, Ben Parks is ill today and isn't able to join us. So we'll be having 2 talks. We'll have a bit of extra time potentially for some additional questions at the end of each talk because of that. So the focus of this session is really around the fact that I think everyone is kind of aware that there's rapid kind of changes and innovations going on in technology, particularly in the kind of the digital technology space, but not solely within the digital technology space. And those hold enormous promise for addressing a lot of the environmental sustainability challenges that we face. So technology can be an enormously powerful tool for helping us to monitor and understand how human activities are impacting on the environment and on sustainability challenges around the world. It can be enormously useful in helping to think about how we can make best use of our natural environments to serve and meet the needs of different human activities and of society, but in a way that is sustainable and preserves the kind of the natural ecosystems and environments alongside the use of those for human purposes. It can also be, as we'll, I think, see in some of the, particularly the latter presentation, it can be an enormously powerful tool for engaging people with issues of sustainability, for thinking about how we can promote behavior change to more sustainable practices. But at the same time, technology also poses challenges. There are, in many cases, big sustainability implications associated with the use of technologies, particularly the use of technologies in the environmental space. Examples can include things like thinking about kind of digitalization. Digitalization, enormously powerful for potentially addressing environmental challenges, but has, for example, big carbon water footprints associated with compute power and all of those factors. It can also bring challenges on the social and the ethical side in terms of who has access to technology, who is able to benefit from increased use of technology in addressing environmental sustainability challenges, particularly around differential access to digital technologies, and what that means in terms of equity dimensions of transitions towards solutions to environmental sustainability challenges. So the first of the talks we're going to have today is from Ciara Mcgrath. So Ciara is, and she can correct me if I get any of this wrong, a lecturer in aerospace systems within the Department of Mechanical and Aerospace Engineering at the University of Manchester. So her background and her research is focusing on developing new sustainable approaches to space mission design, and particularly thinking about how we can address this growing challenge of increased human activity and use of space, and how we can deal with those challenges while still really trying to leverage and exploit some of the real potential and potential for transformation that comes with space technologies and space activity. So Ciara is going to be talking to us about visions of and steps towards an environmentally sustainable space future. So I will hand over to her to start her presentation.
Oh, I'm going to have to skip all Ben's slides. Sorry, Ben. Okay, there we are. That looks like me. Okay, great. So, morning, everyone, and thank you all for being here. It's great to see so many faces in the room. So, as Tim said, my name is Ciara. I'm a lecturer here at the University of Manchester, and I've been here for about 3 years working in the field of space sustainability. First off, let me apologize. I'm recovering from a cold, so my voice is a little bit croaky. As Tim said, wave hands in the back if it's what I'm saying isn't clear. The second thing I want to say is that this presentation is actually one that I prepared for a conference on space sustainability that I was at last week. And the reason I chose to use the same presentation is that this conference that I was at was actually a very interdisciplinary conference on the topic of space sustainability, which is quite unusual. So in my experience, normally when we're talking about this kind of topic, we end up with all the engineers in one room and all the lawyers in another room and all the social scientists in a different room. And this was actually a really interesting conference because it was very small. There was only about 50 or so people, probably about the same as we've got here today, from a variety of backgrounds, but focused on a really narrow topic. And it was a really interesting environment to operate within because we got to be challenged right in the moment. It's very easy sometimes as an engineer, for example, to say, well, we've got this brilliant technical solution, but to then have the people from the commercial side right there and say, well, hang on, how are we going to fund this? How are we going to encourage this from a policy side? What are the legal ramifications of this? And actually have those discussions in real time. And because of that, we were actually really able to move the dial forward, I think, in a lot of those discussions. So that's why I chose to use the same presentation. It does mean I'm going to give you a little bit of context as we go through, because it was pitched at people who were within this field. But I hope that it kind of gives you a flavor of where we're at and what we're trying to achieve in Manchester within this very large scale of problem. So this is an Embury funded project. We kicked off officially in August, but we're really only getting our feet under us, I would say, at this stage. We had a soft kickoff in September, and we had our proper kickoff in October, and we've had a couple of full team meetings since then. So we are starting to get the first steps moving on this project. And just for context, this is building on some work that we did last year, which was also funded by the Sustainable Futures under a small grant. So this is kind of the second step in this project. All right, so this is where I said I was going to give you some context, because it says we're all aware of the growing challenges of space debris. You may not be. So let me give you some context here to start off with. So I'll actually go to the next slide because I think it probably displays it a little bit more clearly. So the graph here that you've got on the bottom left is a little bit squished in the way that it's been translated over, but that's okay. It's a timeline on the bottom, starting from the first launch of a satellite in 1957, Sputnik 1, and running all the way up to 2022, which was the latest year that I could get complete data for, because the numbers kept going up so much that we started running out of capacity to track them in a sensible way. And what you're seeing on the left is the number of satellites that we are launching every year. So what you're essentially seeing is that through the 1950s, 60s, and right through to the early 2000s, the number of things that we as humans were putting into space didn't really change. It sort of teetered somewhere between around 50 and 150 up to 200 every single year. And then suddenly when we got into the late 2010s, those numbers started to skyrocket. And this happened for a whole host of reasons. It was to do with launch getting cheaper. It was to do with building satellites getting cheaper, and a whole host of things. And at the time, we all said, well, this is brilliant because we're all going to be able to do so many amazing things from space. And that remains true. But we're now seeing a whole other challenge. And what's interesting for me, and what's sort of driving the research at the University of Manchester, is that if you look at the news and you read about space sustainability, you'll see that the focus is largely on the in-space challenge. It's largely talking about the number of things we have in space, the risk of them crashing into each other, and the hazards that that poses for us operating within that orbital environment. And to me, that's a very self-serving view of space sustainability, because the risk is to the space industry and to the space players. So it's a view of space sustainability which is valid and true, but it ignores the wider context and only focuses really on the aspects that are a challenge for the industry themselves. So at the University of Manchester, within our group, what we're trying to do is to take a broader view of that sustainability challenge. Because if we think of all of these satellites that we've put into orbit, we've got more than 10,000 active satellites in orbit as of 2024. About 75% of those are SpaceX's Starlink, if not more, although the UK is third at last check for ownership and responsibility for those satellites. So we have quite a lot up there as well. But behind all of those satellites, we reckon there's about 30,000 tons of mass in orbit. And of course, we've been doing a lot of launching to get those things into orbit. So about 200 launches in 2024. So that's more than one every 2 days on average. And of course, behind all of those, there is a supply chain, there is mining, there is manufacturing, there is all of these different processes going on behind them, all of which have an impact on our environment here on Earth. So the challenge for sustainability is not just limited to the space environment. And this is a sped up video of what you would see if you stood at Manchester and looked up over the course of about 2 hours for all of the satellites that would be passing above our head if we could see them with the naked eye. And this is from 2022, so there would be more now. So what we've done as part of our initial program of work, so we started this with that initial grant that we got from Sustainable Futures last year. We only managed to kind of chip the surface, I would say, in terms of what we were trying to do. But what we've done at the start of this Embury piece of work is we've started to try and categorize the problem and understand it. So we've taken some inspiration from some work that's been done by the Earth Space Sustainability Institute in the UK. Who created a memorandum of principles for the space industry in the UK as to kind of areas of concern. So we've taken that and we've extended it and we've tried to divide out what are the different environmental impacts within the space industry that we think we need to be concerned about. And it starts right at the design and manufacture, the mining of precious metals in places where, you know, health and safety and working conditions may not be what we would like to have within our supply chains. And of course, all the environmental impact and carbon emissions that come from that manufacturing and testing process, which is actually quite energy intensive. We've got the launch. That one's fairly obvious. When we burn rocket fuel, there's emissions from that, carbon emissions. But they particularly emit up in the higher levels of the atmosphere. And we think it's possible that the impact up there is worse than what they would be down on Earth. But we don't fully understand what the impact of those launch vehicles are. And of course, all of the launch vehicles have to be manufactured. And even with reusable launch vehicles, we're still seeing the majority of launches, not the majority of launches, but even with reusable launch vehicles, there's a lot of parts that can't be reused, and there are still many launch vehicles that aren't reusable. So we're still seeing a lot of waste around the launch vehicles themselves. Operations is when we're talking about that orbital environment. So I mentioned that's where a lot of the focus has been. Space debris, as much as I say we need to look beyond it, is a serious risk. We've only ever had one highly publicized serious collision, which included an active spacecraft. But spacecraft in orbit are moving at about 7 kilometers a second. So even a speck of paint at that kind of speed can take out a satellite. So the kind of collisions that we get between either active or dead satellites, if we have whole satellites hitting each other, they will create fields of debris that essentially make whole areas of space unusable. So there's a big push to try and work out how can we all operate within this space, move around each other and avoid some of those catastrophic collisions, and essentially all play nice in a regime which is not owned by anyone, but dominated by some really complex geopolitical environments, with Russia, China, and the US being some of the dominant players in the space industry historically. Dark and quiet skies is an interesting one, and it's one that's actually quite relevant to the work that's going on at Manchester, who you may be aware are heavily involved in the development of the Square Kilometre Array, the SKA telescope, which is a ground-based radio telescope. Essentially, with all of these things flying across the sky, if you go outside and you go stargazing now on a clear night, there's a good chance that you will see satellites passing across the sky. And if it's just after a Starlink launch, you can actually see a train of about 20 of them go across in a line, which is quite a spectacular thing to see. But while it's quite interesting as an observer, it's a problem for astronomers. If they're using optical telescopes on the ground, they're getting these streaks that you can see in the image there, contaminating their images that they're trying to detect. And we also get the same problem with radio. So these satellites are emitting radio signals, and those can also interfere with ground-based radio telescopes as well. Space data. So all of these satellites are doing amazing things. They're collecting space data, which is so useful for life here on Earth. But as Tim rightly pointed out, there's downsides to this. All of that data has to be stored, has to be processed. And of course, there's an impact associated with that. Disposal. This is a really interesting one. So with the focus being on space debris and those risks of collision, one of the things that we've moved towards in the past 10 years or so is to try and clean up our orbits after we're finished using them. So prior to that, we would send our satellites into orbit, and at the end of their life, when they died, we would just leave them where they were. And there was sort of a move towards the idea that we should try and design our spacecraft so that by 25 years after they'd finished their mission, they should be removed from the orbit that they were occupying. But that meant if we had a mission that was designed to work for 20 years, it could be 45, 50 years occupying that orbit before it was removed. So we've started now to move towards a system where we're advising people that they should remove their spacecraft from orbit within 5 years of the end of life instead. And we have two options for that. One is that we move them into a graveyard orbit, which is where we essentially just move them to a different orbit out of the way and we leave them there indefinitely. And the other option is that we move them down towards the Earth so that they'll burn up in the atmosphere. And this was considered kind of the gold standard of sustainability in space. But now that we have tens of thousands of spacecraft being put into orbit, there's a serious question as to what is going to happen if we start burning up hundreds or thousands of spacecraft in our atmosphere every year, depositing aluminium and other minerals into the atmosphere that weren't there before. So we've got a real sort of trade-off here between two of these sustainability objectives right from the off. And finally, we've put a category down here for Beyond Earth. So on the Artemis launch that went up a couple of years ago, they took 10 CubeSats or small satellites to the moon. Of those, about 50% of them turned on. So we initially put 5 flying pieces of metal into orbit around the moon. And of those 5 that worked, only a few of them actually achieved their objectives. But as we start going back to the moon more and more, this is going to become more common. And the moon is a more challenging environment. We don't have an atmosphere to burn things up in, and we don't have any graveyard orbits that we've found yet. The orbits are inherently unstable. So if we put spacecraft into orbit around the moon, there's a good chance that they will eventually crash into the moon themselves or cause a problem for other orbiting items. So there's a question here about what is the legacy that we want to leave as we move out into deep space? Do we want to be making most use of those resources that are out there to move manufacturing and so on off the Earth and protect our Earth environment, for example? Or do we want to preserve these environments for their inherent scientific and cultural heritage? So as an engineer, the challenge for us is that as soon as we start our design process and we decide where we want to put our spacecraft, what orbit we want it to go into, and what we want it to look like, we've already fixed an awful lot of those impacts right from the outset. And the changes that we can make further down the line to try and reduce those impacts are small in some ways and also have the risk of having unintended consequences. So we talked about the idea that if we choose to, say, deorbit our spacecraft at the end of life to help to improve that operational environment, there's a risk that we're going to be having a detrimental effect on the atmosphere. So what we're trying to do within our group is to try and understand the interlinks between all of these different harms or these impacts and how we can try and balance them early on and understand them early on in the design process. So, for example, one of the big pushes within the UK is to develop active debris removal systems. So spacecraft that we can launch up into orbit equipped with nets or harpoons or grapplers or other kind of tools to grab old pieces of debris and remove them from orbit. But if we do that, 1, we're going to be burning more things up in the atmosphere, and 2, we're going to be launching more spacecraft. So how do we balance out these different impacts in such a way that we can maximize the benefits that we're getting and minimize the overall harms without these unintended consequences? And There is obviously the question of, should we just stop going to space? And I think particularly for people who are outside the industry, there is this question of, well, why are we doing it at all? We've got people who are putting, cars into space as sort of publicity stunts. We've got people who want to go into space as tourists. Is this really something that we should be spending our time doing and our money doing? But space already today is absolutely vital to support so many things that we do on Earth. It's the backbone of so many things in our daily lives that we take for granted. It provides a high-level timing for financial institutions, for example, the banking systems as we know it today, aircraft tracking, ship tracking, all of those things rely on the space systems that we have. So we can't just get rid of them. And even if we focus in on the environment and climate change, space is so fundamental to what we do. It's one of the key ways that we track our impacts on the climate. And there's also really tangible ways that we can use space systems to potentially address some of those climate challenges going forward. So everything from, helping to inform more efficient farming practices by using space observation data, helping to improve logistics management for shipping and moving things around the world to try and reduce the amount of inefficiencies within that system. And of course, it's really vital in how we predict extreme weather events and respond to those disasters, which we know are becoming far more common. And if we look further into the future, there's all sorts of things that we can consider using space for, from space-based solar power, so harvesting energy from space and transmitting it down to Earth, or pushing our server farms into space so that we're removing that source of heat, which is a huge contributor to climate change here on the Earth. So if we rule space out, we lose an awful lot of options. Okay, so where does that's the background of why we're doing this. So what are we actually doing as part of the Embury group? So it is a really interdisciplinary project. We have a big team across multiple departments within the university. And we also have some industrial collaborators as well, which is a really exciting thing to be able to do and work on. So essentially within the project, we have two goals. The first is that we want to work with stakeholders to create clear visions of what a positive future in space could look like. So as I mentioned, do we want to be preserving those deep space environments? Do we want to be maximizing the number of spacecraft that we can put in orbit so we can get the greatest benefit from all of these incredible space technologies? Or do we want to be controlling space, for example, so that we're only putting the most important systems into space and minimizing our overall impact? The second thing we want to do is we want to understand from these stakeholders which of these impacts or harms are most important and concerning to them. And then we want to try and understand how those different harms relate to our design process. So where are those design choices that we make as engineers that are the hot spots, that are the most likely to cause some of these negative harms? How can we make some tweaks to try and improve them? And where are the other areas where we're likely to accidentally cause unintended side effects? And how can we kind of watch out for those as we move through the design process? So bringing together these workshops into a framework, we want to try and create guidelines so that we can understand how we can approach this design better in the future. But just to finish up, I think what I wanted to do was talk about two things that are specific to the sort of interdisciplinary element that we've learned going through this process. And the first thing that I wanted to say was, people always talk about working in interdisciplinary teams as being really challenging. People have different languages, different words for things. Trying to create that understanding can actually be quite difficult. And so the thing that I think I've learned from working through this project that was most important was having a team of interdisciplinary academics and researchers who were comfortable enough together to be able to actually say when they didn't understand something or when they thought something was wrong, and B, who were really enthusiastic, excited, and engaged in the process, and were able to commit time to bring their energy and their resources to the project. Because I think without that, we wouldn't be as successful in this work as we have been to date. So I think for anyone who's working working on these projects or looking at an Embury grant in the future, I would say don't underestimate the value of making sure that you build those connections early on, whether it's over coffee, whether it's with seminars, whether it's over pizza, but building those relationships such that people can bring those opinions and feel safe and comfortable to bring those questions and opinions to the table is so, so important. And getting everyone in an actual room that isn't a virtual environment is incredibly valuable. And the second thing that I found to be really useful is to create a realistic set of expectations at the outset of what everyone's going to contribute and bring to the table. I think when you're coming in, especially when it's a topic that maybe you're not hugely familiar with and it's unclear how your skills are going to be valued and used through the project, setting out really clearly at the start of the project what the time scale is, what meetings are we going to have, what conference papers are we going to write, and so on, and who's going to contribute to those and in what way. I think having that agreed right at the start was really helpful because I think it made everyone see how valuable their contribution was at each stage of the project. And also they could see where they weren't needed and they didn't need to turn up to the meetings and they didn't need to respond to the emails. So I think creating that balance of helping people understand what contribution was so important, but also where it wasn't needed was really valuable. And the final thing is, what do I think is the most valuable aspect of interdisciplinarity in terms of this work? And I could talk about a whole host of them, to be quite honest, even at this early stage. But to me, the most interesting thing that I didn't expect was when we came to set up these workshops and start planning them. And I kind of had this preconception that, okay, we're going to run some workshops. We'll put some experts in a room. We'll ask some questions. We'll write some things down. How difficult can it be? And when the team from geography, who are social scientists, looked at this, they brought such a wealth of experience and knowledge to the table that I will readily admit I completely underestimated the capabilities and the skills and the science that went into this. They really looked at what are our aims and how can we shape our workshop to elicit the responses that we really need to get from the people that we're going to have in the room. And I was just blown away by how much better we could make these workshops and how much we could go beyond what I had initially envisioned. And I think what's really exciting about that is I have no idea what we're going to find. As an engineer, I think you go into these things and you've got an idea of what we're going to try and achieve. And now I'm going into it with the knowledge of the background behind me, but no knowledge of the methods. I think the geographers are going into it with a knowledge of the methods, and now they're familiar with the topic, but they're not familiar with the experts we're going to put in the room. And so none of us know what we're going to find. And I think as a researcher, there's nothing more exciting than being able to take on a problem and be genuinely excited and surprised by the results. So that's everything that I wanted to say. Thank you very much.
So I think we've got time for one question. If anyone from the audience has a question for Ciara.
That's that's a really good question. And just for anyone who didn't hear, the question was about how do you identify these stakeholders, because it's such a, and thinking beyond the obvious. And this was another place where the interdisciplinarity was actually really valuable. So again, going into it, we had our own industry contacts, we had our own academic contacts who we thought we would include. But we actually kind of had sort of one of the things we did as part of the kickoff workshop was we tried to figure out who those stakeholders would be and what they might be. So we kind of approached that in a couple of ways. One of the things that we did was we kind of wrote down on different pieces of paper the different kind of titles of each of the person and people involved in the project. I wrote that, and it just goes to show how little I knew because I got them wildly wrong. But and we got everyone to write down what questions did they have around those fields. And in some ways that helped us identify where we were missing expertise in the room and where we could answer questions and where we couldn't. So that was one thing. But then the second workshop that we did, which was run by our colleagues in geography, they set up a sort of an axis of, people within the space industry and not in the space industry, and those who were kind of technical and non-technical. And what they actually did was they got us to all bring an item of something that would be affected if the space industry collapsed. And we talked about who could help us solve that problem. And then we had to put them all down on this chart to see where they fit. And through that, identify where were there gaps of people that we'd missed. And we started to try and think outside the box then of how we could fill that in. So the kind of two sides coming together. So we're still finalizing. But yeah, we've gone way beyond what I ever would have thought we would have included.
Great. Thanks very much, Ciara, for a great talk. So we are going to move on. Hopefully slides will change correctly. So we're going to move on to our next talk, which is from Suzanne Embury. So Suzanne is a reader in the Department of Computer Science at Manchester, with a background, I think, in a variety of aspects of kind of software design and software-related research. So this is a project called Video Games as a Transformative Medium to Engage the Public in Sustainability Research. So this is work that you've done jointly in collaboration with Professor Ricardo Clement, who is a professor of interactive music composition, if I can get my words out, at the University of Manchester as well, and is the founder of the Novars Research Centre. So yeah, really interested in listening to your talk, Suzanne.
Great, thanks very much, everyone. This project, it's all done and dusted. We finished it, so it was a great opportunity for me to come today and remind myself of the fun stuff we got up to in it. It's very important to mention that Ricardo really is here in spirit. You'll see a lot of his work, a lot of his ideas. He's really been one of the main driving forces behind this research. He couldn't make it today. He's off talking about this work somewhere else. So this project started before COVID with a project that Ricardo worked on with his social responsibility spin-out called Keep It Human. And one of his interests at that time was in how can we get more philanthropy amongst young people, because the age of people giving to charity and working with charity is rising. The average age is rising dramatically. And because he's a professor of interactive music technology, he very much wanted to do something that would engage younger people with philanthropy. And he came up with this idea of a game which has virtual to real conversion. So the actions that people undertake in the game result in actions in the real world as well. And with this game, he had some crowdsourced donors, and people would play in the game. And as a result of their actions in the game, skateboards would be donated to children in Mozambique. So there was a real connection between what happened in the game and what happened in the real world. And I think this was just before COVID. And even during COVID, Ricardo set up some live stream concerts in the game world. So it was able to bring people together and really interact with one another when we'd all been stuck in our rooms, twiddling our thumbs for a while. And then just after COVID, we were just starting to get back into the real world again from our virtual world that we'd been stuck in during COVID. And at this point, my project, Imago, connected in with Ricardo. So Imago, we call it a student software company. We're not really a company, we're an internal university project. In the Department of Computer Science, we have 1,000 undergraduates who love coding. They can't stop coding. They're desperate to code. And also we have a situation at the moment where the job market, there's high demand for people with coding skills, but there are also many, many graduates with great degrees from top universities like ours. So having real experience of working on projects really helps our students. So what we do with Imago is I put together teams of students to build software for academics, and we pay them, so there's no barrier for people who have caring responsibilities or who are time poor, money poor. and time poor, we can get them involved in our projects as well. So we got together with, at that point, Ricardo was working with a charity in the Philippines called Oceanus, and they work with mangrove regeneration. So there are many sites in the Philippines where it was a beautiful, pristine mangrove forest that was converted into some kind of industrial port facility for fishing and that kind of thing. And then the fish all died, and then they couldn't use that anymore. So there are many abandoned brownfield sites that used to be mangrove sites and are no longer in use. And so Oceanus works at putting them back to be mangrove sites again. Mangroves are a great source of blue carbon as well, and a great way to build up the environment back again, and it gives work for local people. So in our project that we did jointly, we created another game called Mangrove World. Because it's me, one of my areas is software discovery. So it doesn't work if you let people who don't know anything about software tell you what the software should do, because you have to know what software is capable of before you can really decide what the software should do for the best. So that doesn't work. But it also doesn't work if you let just software engineers like me decide what the software should do, because we haven't got a clue what the real change that software should make in the world is. We don't understand the domain. So really you have to put both of those people together to work and in a way to discover what the software should do through a series of small scale experiments. And I love paper. So if anyone works with me on software, you'll know that I'm always getting the crayons out and the scissors. I love paper as a mechanism to help non-technical people work with software, decide what the software should do, play around with ideas, and as a way to communicate those ideas to the software engineers. And we use paper, as you can see here, not just as a way to draw or sketch out what the software might look like, or to just try some ideas out, but actually to build a working prototype that you can try. So here we were building games that might possibly encourage people to know more about mangroves, and we were actually playing them in their paper-based forms. And this was very successful. In fact, that's Ricardo at the back there. I told you he was going to be present in this talk. He went out as part of the project. He went out to the Philippines, and in continuing this idea of virtual to real conversion, they installed audio loggers in the mangrove forests so that through those recordings, the species could be identified, the health of the species, the number of the species could be identified and tied into the game semantics. So that was where we were at before our Embury grant, which is the one I'm going to talk about today. It's not EO games, but video games. I don't know. I must have made my slide a bit too long. Sorry about that. So yeah, so we thought, well, this has worked really well with these two games that we've worked on so far. Could we use video games as a way to take the sometimes quite complex and dry, but very important research results that people are developing across the university in the area of sustainable futures and really convey those ideas to the public through the medium of video games? So we came up with this game called Resourceful World. You can Google it, and here's a little snapshot of the main character in the game. We decided to target primary school age. There's a big difference in video games between teddy bear clicker games and Grand Theft Auto. So you kind of have to choose your audience a little bit. And we thought, let's get them young. So we started with primary school children. So think of that, bear that in mind when you see the graphics. So the method, we kind of built on the method that had worked so well with Mangrove World. We started off running some workshops with academics. We ran workshops with academics from Healthy Futures and academics from Resourceful Futures. And we're really grateful to all the people who came to our workshops and came and chatted with us and entertained our daft ideas. It was super, super useful. And I think there's at least one of our academics who's on this picture here. Jing Li, thanks if you're around for the support on that. So we started off with, again, paper-based workshops where we talked to the academics about their research results and what it was they really wanted to convey to the public and how that might be converted into a game. And we did that with, as I say, a couple of groups of academics. We use paper prototyping again because it's me. And we use Lego and small toys and all kinds of things to try out some different game worlds. And then we had a professional storyteller, Robin Lyons, who has an MSc in environmental conservation. And he came in and took all the data we'd gathered from the academics and created a narrative framework that could be used as a sort of general story, and to which these different results could be, academic results could be fitted. From that, we built a basic open world within the game environment, and we built some character designs. Here are some examples. So that's bioenergy is on the left. I'm sure you can guess hydroelectricity is next along. That wind power is the big pink guy there, and solar. So we also created characters for fossil fuel types of energy and a number of other NPCs, non-player characters. So we came up with this idea of having lots of mini planets in the world, which would each focus on a different research concept that needed to be got across, and that the player character would move between those planets and meet different kinds of characters as they went. And then this is where my Imago students came in. We had a team of 6 Imago students, and they came in and started to play with those activities and create mini puzzles themselves and just try out different ideas. So yeah, so big thanks to all the academics who came and to any of our workshops. We ran, as I say, 2 of those, and it was super, super useful. This is the cast of thousands that Ricardo managed to employ on the grant. So you can see we've got a whole range of different skills. We've got a storyteller, Robin, as I mentioned, Benoit, who came and composed the music for us. You'll hear some of his music later. Very important in creating the emotional response to some of the ideas in the game. 3D modeling, analytics and game devs. Shun was very important in creating a simulation engine within the game that allowed us to model simple results that are based on a mathematical model. Again, you'll see some of that in the example. Yeah, Hong Shuo Fan, who was our dev lead, he was great. He led most of the coding, and all of my students down at the bottom in smaller font, just because they've got long names, not for any other reason. They did a great job for us. So what we ended up creating was a toolkit, a demonstrator game in Resourceful World, but also a toolkit which we hope other academics could take and say, yes, I can see how my research result could fit into that toolkit, and use those building blocks to, more quickly than we did this first time, create a game that would convey some of their own research results. So we've got all these building blocks. One thing they can do is, of course, raise awareness of particular challenges, but that was kind of, I think, the least interesting of the results that came out of our first attempt at this. Because we could put this simulation engine in, we were able not just to say, oh, this is a bad choice because, but to put the player in a situation where they could explore a range of different choices and see what happened. If I do this, if I don't throw my coffee cups into the recycling, but instead I throw them over here, in the scope of a game world, a small game world, you can speed up those effects and you can make them apply to the player character instead of course, at the moment, the bad effects apply to people far away in another country. But something else very interesting came out of this, and this came out of our workshops with the academics. So again, thanks to them, we realized that the knowledge transfer needn't only be one way. So we thought that this would be a transfer of ideas from the academics to the player of the game, but we realized that there was a way to get information from the players to the academics. So if you weren't sure, as part of your research, you wanted to know how likely are people to make a particular choice? Do people understand the difference between materials well enough to know which recycling bin to put them in? You could set a puzzle for that and then run it with the public and then gather the stats on who made what choice and bring that information back into your research. Yeah, so those were all the great things that we saw. So I'm going to, if I can figure out how to play, I'm hoping that Alex or someone's going to help me figure out how to play this. All right. So I'm going to show one of our shorter game trailers while I show it, you can just enjoy the fun graphics, or also think about the narrative and how it's a sort of generic narrative that many, many results could be included in. Let's see if this works. Oh, yes. Okay, so that just gives you a little hint of the game. I hope you see how important the music was there in setting the atmosphere and making an emotional connection to the goals of the game. What's happened since at the end of that project? Well, we've got our demonstrator of the Resourceful World game. We've got our analytics engine for gathering data about what players do in the game, and also the simulation engine. It can simulate weather conditions, for example, but also processes, energy-based processes, health-based processes. We've created a grants proposal toolkit. So our hope when we set going with this was that people, academics around the university might see some value when you're setting off writing a research proposal. You might think, it might be nice at the end of all this to have a game to be included in the resourceful world. And therefore you might write into your grant proposal a small amount of money to add your game into the world. So we created a grant proposal toolkit for helping that to happen. Ricardo's been very, very busy. He's been presenting this game all over the place at Blue Dot Festival. MMM6 is a mangrove management conference that was held in Colombia. He took it to Gamescom 23, and he's just recently taken it to all his games to the Manchester Science Festival. I haven't heard yet how many people came to play, but when he went the year before, it was very, very busy at his stand. So we're expecting it to be the same. His latest game, which Imago wasn't involved in, and you can see it's in a different world as well, he's done in conjunction with some researchers in fast fashion. And the game helps people to understand how the choices that they make with fast fashion can lead to pollution, using the same kind of principles that we've been using in Resourceful World. So that's the project. It was a super experience for me, and I have to thank Ricardo and his team a lot. It would have been a much more boring game if it had been just me developing it. So it's thanks to Ricardo's creativity and the wonderful team he was able to put together. You can see it really is an interdisciplinary task to get something like this put together. So you can find out more about the game on keepithumanitch.io if you're interested, or you can contact either Ricardo or myself if you'd like to hear more, or you'd like to work with Imago on some of your projects, or you'd like to get put into the game in our next version. Thank you very much.
So we've got time for one or two questions for Suzanne, and then thank you for a fascinating talk. It's already stimulating.
Great. I can just play the trailer again if you like.
We're going to try and bring one of the microphones up to people who've got questions. So if you stick your hand up, I think there's one right in the very back.
Thank you. So my question is, I'm sorry if I missed it, but in terms of the impact experienced by the game players, what kind of data were you collecting on that? Like, you know, surveys, for example, before or after the experience? And is there more opportunity to be collecting more data about people's responses, you know, maybe even through novel technologies like facial recognition or, you know, brain stimulation, and what kind of emotions are being elicited from playing?
Wow, yeah, you're going much further than we have there with brain stimulation. I mean, I hope we were achieving some of that, but we certainly weren't measuring it. That's a super interesting idea. Because this was a pump priming project, we were able to create the game and kind of prove the concept in some informal trials, but we didn't get to do any science after that on the result. So we haven't been able to prove that this has an effect on people's behavior or anything like that. It's definitely just a beginning, but we would hope to do that. We'd probably need to bring in another discipline on that, perhaps from psychology or someone from social sciences to help us do that properly. So yeah, we haven't done that yet, but it is something we would hope to do. We certainly haven't got as far as putting devices on people's heads while they play, but yeah, if you've got ideas in that department, I'd love to hear how we could do that for the future.
Hi, thank you. It might be a slightly cheeky question given you're a software programmer, but you started with paper and scissors and crayons, and I wonder if ever when you're developing these sorts of games you think, you know what, this is better with paper and physical objects than it would be as a computer game. And so in terms of and what might be the reasons that you would choose one over the other, whether it's to do with different sorts of collaboration people could engage in with physical objects that they're working with in a game, or different types of learning processes going on when you're also manipulating a physical object rather than just working on a screen.
Yeah, sure. So one of the luxuries you have as a software engineer, computer scientist, is that you don't have to think everything about tech is great. So I would absolutely agree. Definitely, sometimes the real world paper is great, and I know that people have built board games and have built card packs and things like that to try and engage in exactly the same way. And I would absolutely go along with that. And sometimes we come out of as a software engineer, software is so expensive and it lives for so long, and you have to keep pouring resources in to keep it going. Any good software engineer you talk to should say that they try and avoid building software at any cost. So we try to only, build the software unless we're having fun with the game, but we try and avoid building software. So if the same result can be achieved, and that comes out of our paper workshops, that's absolutely great. But also we have the option now of having augmented reality and having games which do interact with the world. So it's not a choice anymore of, it's an analog game, it's in the real world, or it's a tech game in the computer. We can have a mixture of the two. Obviously, Pokemon Go is the most famous of that, but there's lots of opportunities, I think, for sustainability research to be put into augmented reality games, where people are taking photos of their environment and they're labeling things up. And I think that there's lots of potential there for that kind of thing. The good thing about a game like this is you get a little world in microcosm and you control everything. So you can control the scale of it, you control the options, you make a complex, horribly complex environmental problem comprehensible enough for people to engage with. So that's its strength, I think. But you need the imaginative leap then to connect that to the real world. I'm sure we'd have people who in the game would recycle very responsibly. Oh yes, I'm definitely recycling my cups, but in the real world would chuck it in the bin rather than walk 100 meters down the road to the recycling center. So yeah, it has its limitations.
stuff.